All right, Chapter 6, Section 3 in college algebra. So if needed, the substitute can pause the video for you all to catch up. Section 3 is still about solving systems of equations. We're back to just two equations. Section 2, you had 3 equations in your system. We're back to 2 equations, but instead of being simply 2 lines or linear equations, we're going to have some shapes that are not just lines. So what does that mean? Well, look at this first graph up here, and you can see that there's a parabola and a line. This system of equations has a parabola, the first equation, and the second equation, a line. So what happens to intersect at 2 locations? So instead of there just being one solution that works, there are 2 solutions that work. The second situation here happens to be an ellipse and a hyperbola. We graphed those in our last chapter, and we're not graphing them again, but if you remember some of that, it will be helpful. So if I have an ellipse and a hyperbola in this situation, there are 4 locations where they intersect. So there are 4 solutions to this system, just like there were 2 solutions to our first situation. And then it's possible, in this last one down here, we have a parabola and a circle, and these don't intersect at all. So if they don't intersect at all, there's no solution. So we can have a varying number of solutions. 1 all the way up to 4, we won't get any higher than 4 solutions, or maybe no solution, nothing works at all. But the methods we will be using are the same algebra methods of substitution and elimination that we reviewed in our section 1. So looking at example 1 here, we are to use the substitution method, they say. Excuse me. Well, if you look at this, the first equation has been solved for y. So it works very easily for substitution. I can take that value of y and substitute it into the second equation. So if I rewrite that second equation, 3x minus my y value, and I need to put it in parentheses because I'm subtracting the whole value of y, which is that x squared minus x minus 1 from equation 1, equals 4, continuing to write equation number 2, substituting into it. Okay, well, we need to simplify. I need to distribute that negative. So 3x minus x squared plus x plus 1 equals 4. And we need to try to solve this. Well, looking at this, I have a quadratic, a second-degree equation. I'm going to get it equal to 0. Now, I'm going to put my 0 on the left side because I like my squared terms to be positive, and I notice I have a negative x squared. So I can move it to the right side by adding it. So that'd be a positive x squared. And then I need to take care of all the others. Now I have a 3x and x. Those like terms together would make a 4x. So I'm going to subtract 4x to bring it to the right side. We have a positive 1, so I need to subtract 1. 4 minus 1 is a positive 3. So we have it set equal to 0. Now I can factor to see if I can't solve this. So factoring this trinomial, x times x would be x squared, multiply to be a positive 3, and add up to be a negative 4. Negative 3 times negative 1 would be a positive 3. Add them together, we get a negative 4. So the values of x that make each of these factors equal 0 would be a positive 3 and a positive 1. So I have 2 possible values for x. So my solution set, I can have an x with a 3, comma, some y value, and an x with a 1, comma, some y value. So to get my y value, well, back up here in equation number 1, we know what y equals. So I can use that to get my y value. And if I have an x value of 3, my first situation, 3 squared minus 3 minus 1. Substituting my x value into that first equation. So 9 minus 3 is 6, minus 1 more is 5. I get a 5 when my x is a 3. When my x is a 1, in that equation 1 again, x is 1. 1 squared minus 1 minus 1. So 1 squared is 1, minus 1 is 0, minus 1 more is a negative 1. So there's my solution. I have 2 points that are solutions to this system. The first equation is a parabola, the second equation is a line. So there's the graph, and you notice there are the 2 points, 3, 5, and 1, -1, where they intersect. So my solution to that system. Example 2, elimination method. Here I have a couple of squared terms, both x squared and y squared. So solving for an x or a y would not be the easiest way to approach this one. But I want to try to eliminate either my x or my y terms. It doesn't matter which one we decide to eliminate, but let's say we wanted to eliminate the y's. So if I want to eliminate the y's, they both go into the number 6. So I can multiply one by a 2 and the other by a 3, but I also need opposite signs. So one of them needs to be a negative. I'm going to pick the first one as a negative. So that first equation, distribute that -2, multiply everything by -2. So -8x squared minus 6y squared equals a -96. Second equation, everything by a 3. 9x squared plus 6y squared equals 105. Now I can add these together, and the y's will eliminate. That's why we set it up. So -8 plus 9, that's 1x squared, or x squared. Y squared terms are gone, equals, add those last two numbers together, we get a 9. So I need to solve for my x. Well, to get rid of my square, I need to take plus or minus the square root of that 9, which gives me two answers, a +3 or a -3. So just like earlier, I have an x value that can be a +3. I have an x value that can be a -3. And we need to figure out the y's that go with it. Well, we will substitute back in, and it doesn't matter which equation we substitute back in. I'm going to pick the second equation simply because 35 is smaller than 48. My numbers are smaller. So let's start with that 3. X value of 3 into the second equation. 3 times 3 squared plus 2 times y squared, that's what we don't know, equals my 35. I just substituted an x value of 3 right here in that second equation. So let's see, 3 squared is 9, times 3 is 27, so 27 plus 2y squared equals 35. Subtract our 27, 2y squared is going to equal our 8. Divide by 2, y squared equals 4. In order to get y, we're going to have to take plus or minus the square root of 4, which gives us 2 values, plus or minus 2. So when we substituted a 3 in, I have 2 potential y's. I have a +2, and when I substitute 3 in, I get a -2. I got 2 solutions when the x was 3. When the x is a -3, I'm going to do the same equation, that second equation, 3 times a -3 squared plus 2y squared equals 35. So substituting my -3 and my x. Well, -3 squared is a 9, times 3 is 27, and this equation should look familiar. It actually ends up looking just like the other one. Subtract my 27, divide by my 2. In order to get y, I'll take plus or minus the square root of that 4, which gives me a plus or minus 2 again. When I put a -3 in, I can get a +2, and when I put a -3 in, I can get a -2. 2 solutions from having a -3. So there are actually 4 answers to this one. If we looked at the graph, it happens to be 2 ellipses, and there are the 4 solutions, or the 4 places where these 2 ellipses intersect. Now, it's actually possible to shorten down these 2 pairs that I have right here. When I have a +3, we got 2 answers to that +3 for the y, a plus or minus 2. And when I had a -3, I got 2 answers, a plus or minus 2 for the y. So that would be acceptable. You can't shorten it any more than that. You can't say plus or minus 3, comma, plus or minus 2. because then you're not distinguishing which x and y actually can go together, and you can get the wrong ones together. But it would be acceptable to shorten those 4 down to these 2 I have in green. Example 3. We again have a situation where I have squared terms, so I'm going to want to try to eliminate to get rid of it. So let's try that same technique. And I can eliminate the x's or eliminate the y's, it doesn't matter. I'm going to go for the x's this time. So I could multiply this bottom one by a -4, and that would allow those x's to eliminate. So -4 times that bottom equation, -4x squared plus 4y squared equals a -100. First equation I didn't need to change at all, so I'm just recopying it. And then we'll add these 2 equations together. It eliminates those x squared terms. 4 and 9 makes 13. 13y squared equals a -64. I could divide by 13. Y squared equals -64 over 13. Doesn't go unevenly. And then if I was wanting to get a y, I'd have to take plus or minus the square root. Well, here's the issue. We can't take the square root of a negative number and get a real solution to it. So there's no solution to this one. So whatever these graphs are, we'll look at them in a minute, they don't intersect. No solution. So that's why it was called an inconsistent system right up here. So that's what a possibility is when we get an inconsistent one, is something comes out that we cannot do or is not true. Happens to be an ellipse and a hyperbola, they don't intersect. There's no solution to that system. Example number 4. In this one, we are going to have to multiply out our binomials that are squared before we can do any work on them. Both of those binomials in the first equation, we're going to have to multiply out. And the same thing in the second equation. We are going to have to multiply them out. So if I call this equation 1 and start with equation 1 out here, x plus 3 quantity squared. Remember, that means x plus 3 times x plus 3. Let me write that off to a side for just a moment. X plus 3 times x plus 3. That's what it means when I have x plus 3 quantity squared. Now you can use FOIL on that. First terms would give us x squared, outside 3x, inside 3x, so that'd be a total of 6x. Last term's 9. It's also a formula you may remember. Y minus 4 quantity squared. Y minus 4 quantity squared means y minus 4 times y minus 4. It'll be y squared minus 8y plus 16 when we're done multiplying it out. Equals 20. So there's the first equation. Second equation, I need to do the same thing. I need to multiply out my binomials. So that x plus 4 quantity squared. It'll be x squared plus 8x plus 16. Y minus 3 quantity squared plus y squared minus 6y plus 9 equals 26. Now we can take this system and we can eliminate. So I want to eliminate my x squareds, I decided. Any squared term is what you would want to eliminate first. So I'm just going to multiply this first one by a negative, write it right underneath here. So it'd be negative x squared minus 6x minus 9 minus y squared, every sign changes, plus 8y minus 16 equals a negative 20. I didn't have to change that second one. So now I can just add these last 2 together, and it will eliminate my x's. 8 minus 6 is 2x. 16 minus 9 plus 7. Negative and or positive y squared and a negative y squared, they also were eliminated in this case. So negative 6 plus 8 plus 2y, 9 minus 16, negative 7, 26 minus 20 is a 6. So let's simplify this. 2x plus 2y, 7 minus 7, well those cancel, equals 6. we're down to this equation. I need to take that equation and solve it for a variable, because I can't get an answer yet. I have two equations, or two variables, an x and a y. I'm going to solve it for y. I'm going to divide everything by 2 first. X plus y equals 3. Just dividing everything by 2. And then I can subtract my x to get the y by itself. Subtracting my x, negative x plus 3. This is a value of y that I can now substitute back into one of my two expanded equations. Those are the original equations, they're just expanded. I eliminated my squared term, which actually eliminated 2 of them. And then I rearranged this equation down to solve for one variable. Now I'm going to substitute this value of y, and I'm going to pick the first equation. Doesn't matter which of these two I pick, either one would work. So I have a value for y that I'm going to come through here, and wherever my y's are, I'm going to substitute what y equals in those locations. So I'm taking, make a little asterisk here on this equation, I'm taking that equation and I'm substituting what y equals. X squared plus 6x plus 9 plus my y is squared, and my y is a negative x plus 3. And it has to be squared. Minus 8 times my y. Minus 8 times my y, negative x plus 3 is my y. Plus 16 equals 20. Plus 16 equals 20. That was that first equation. Now there only are x's in this equation, so I should be able to solve that equation. We'll have to do some multiplying out, some simplifying here. X squared plus 6x plus 9. Now I need to square this, which means I'm multiplying it by itself. And if I multiply it by itself, I'm going to get an x squared minus 6x plus 9. You can double check. You can take negative x plus 3 times negative x plus 3. I need to distribute my negative 8 right here. So plus 8x minus 24 plus 16 equals 20. I'm going to get like terms together. This is just a quadratic. It's a trinomial once I get all my like terms together. So x squared plus x squared, that would be 2x squared. My x terms, I have a 6x, a negative 6x, so those are gone, an 8x. So all my x terms together, I end up with just an 8x. Then my numbers. I have a 9 plus 9 more is 18 minus 24. So 18 minus 24 would be a negative 6. Plus 16 would be a 10. And then I'm going to subtract this 20 from my 10. So 10 minus 20 is a negative 10, so that I have it equal to 0. So all we did on that line was we combined our like terms and made it equal to 0. Well, I want to factor this, but I notice a 2 is common, so I'm going to factor out a 2. X squared plus 4x minus 5 equals 0. And now I can factor this trinomial and see if I can solve for what values of x make it equal 0. X times x will be x squared. Multiply to be a negative 5 and add up to be a positive 4. 5 times negative 1 is negative 5. Add them, it's positive 4. So the values of x that make each of these equal 0 are negative 5 and a 1. So my answers, my x can be a negative 5. We'll need to figure out the y that goes with it. My x can be a 1. We'll figure out the y that goes with it. And in order to figure out the y that goes with it, well, I'm right back here to this one we used a minute ago to substitute. That will tell me what y is. I'll just need to substitute my x value into it. So y is going to have to equal negative of my x value, which is a negative 5, plus 3 more. We're using this equation. So that'd be 5 plus 3, I get an 8. When my x is a 1, negative of a 1, and then add 3 more. So negative 1 plus 3 would be a 2. 2 solutions on this one. Negative 5 comma 8, a 1 comma 2. Those original equations happen to be 2 circles, I think. Let me look back at those equations. Those happen to be 2 circles is what they were. And so those 2 circles intersect in our 2 locations, negative 5, 8, and 1 comma 2. So let me review what we did here. It's probably our most complicated one. We had to distribute, multiply out these binomials. So these binomials, x plus 3 squared and y minus 4 squared, had to be multiplied out. So that gave me a new equation 1 and equation 2 that were multiplied out. And then I eliminated my squared term. So we multiplied the first one by a negative, and we eliminated the squared terms, and both of them were gone. I solved it for a variable. So there we got our value for y. And then I substituted that back into either of these first 2, and I picked the first one. And that was the first place where I only had one variable. I only had x's, and we got our first answer, what our x's could be. And then we substituted them back. Last one. Screen of a plasma television has a diagonal of 63 inches. When you see that advertisement, or you go to the store and they say, hey, this is a 55-inch television. It's not 55 inches across. They measured the longest length that they can measure on that screen, which is corner to corner. So a 63-inch television, that's the diagonal of 63 inches. It says the ratio of the width of the screen x, so they want the width to be x, to the height of the screen y, so they want the height to be y. They say that ratio is a 16:9 aspect ratio. Wide screens or standard screens, they have different aspect ratios. Do much with video or videography, then you've probably run across that before. They want us to figure out the width and the height of this screen, and they want it to round to the nearest tenth. Okay, let's take the first bit of information that they have said, and that is this ratio of the width x to the height y is 16:9. So I know that the ratio of width x to height y is 16:9. So that's an equation that is implied from that very first one. The next thing I see is in the picture. We have a right triangle here. And that right triangle, we can apply the Pythagorean theorem. We know in a right triangle that a leg squared plus another leg squared has to equal the hypotenuse squared. So I have been able to set up 2 equations. Now we want to solve this. So let's take that first equation, and we are going to cross multiply. X times 9, 9x, must equal y times 16, or 16y. And then I can take this first equation that I've cross-multiplied, solve it for a variable. I'm going to solve it for x. So I divide by 9. 16y over 9. I have a value for x. So I can now substitute into equation 2. So equation 2, I have a value for x that I can substitute. So where x is squared, well, x is 16y over 9. 16y over 9 has to be squared. Plus y squared equals my 63 squared. 63 squared happens to be the number 3969. I, of course, did that in my head while you were listening to me. Not really. Solve this. So I need to square this fraction. 16y over 9 squared, I square everything. Square that 16, we get 256. Square the y, we get y squared. Square the 9 on the bottom, we get 81. Like terms together. I have two y squared terms. I need to add 256 over 81 plus 1. So if you get a common denominator and add those together, you can use your calculator. You would get 337 over 81 y squared equals 3969. That's from adding these two things together. There's 1 in front of that y squared. So 256 over 81 plus 1 is 337 over 81. Now to get my y squared by itself, well, I'd multiply by the reciprocal. To get rid of this fraction, we'd multiply by 81 over 337 in order to eliminate that fraction on the left side. And when you do that, and since they're wanting us to go to decimals, I'm going to go ahead and go to a decimal at this point. It's 953.97. And I wrote a 6, didn't I? 0.97. So I want y instead of y squared. So we'd say, well, I take plus or minus the square root. Normally we do take plus or minus the square root. But since y stands for a length of the side of the television, we're not going to have a negative length to the side, so I'm only going to take the positive square root of it. And the square root of that number happens to be approximately 30.9. So there I have a y value. And if I have a y value, well, then I can come back over here and I can get my x value. My x must be 16 times my y value, which was 30.9, divided by 9. And that gives us an x of 54.9. So I have my x value. They wanted to know, what are the dimensions? What are the width and height of that television screen? Well, width was the x, so we won't call it x. We'll say the width is 54.9 inches, and the height was the y. We won't say y. We'll say the height is 30.9 inches. So there are the dimensions of that television screen. All right, that is Section 3, Chapter 6, Section 3. You have your syllabus, and so you can begin working on that, and it could even be replayed, any of these examples, if you need them replayed, or they'll be posted to Edmodo.